So just in terms of the website, we're still behind this card here. And I'm going to talk through these slides today, which means that you should be able to complete this lab here on the right after today's lecture. So just check that people can see my screen. Isn't that okay?
It's okay. Everything's good.
Great. So we're still on the fundamentals, as I'm calling them, but today it's all about behavior. And just as we had objects last week as the main unit of composition when it came to data, with JavaScript, we have functions as our main unit of composition. Now, if you know anything about JavaScript in more recent years, you will know that classes have been added to the JavaScript language. They're not native, though, to the language. They're actually converted back to functions kind of behind the scenes. But there are classes in the language. Now, we won't need to use classes at all at any stage throughout this module. So functions, at least I don't anyway, and I don't think in the second half when Frank comes in, I don't think he needs to use classes either. So it's functions all the way, which is kind of nice because that's what's kind of core to the language anyway. And I'm saying here that functions have been part of the language from day one. So when I'm talking about ES5 and ES6, like I said last week, when we talk about ES5, we talk about old JavaScript, if you like, or vanilla JavaScript. And in vanilla JavaScript, we had function declarations, function expressions. There were two different ways of declaring functions, essentially, and we'll look at both of them in a moment. There was this odd feature as well called hoisting. It's not really an issue anymore, but what hoisting really meant was that no matter where you declared a function in your JavaScript file, at runtime, that declaration was actually moved to the top of the runtime environment. Now, I'm not sure why that was part of the language. What it meant as a consequence was that in your actual physical JavaScript file, you could invoke a function before it was declared. The declaration came after the invocation as the code looked physically in the file. And the reason that was possible was because at runtime, we had this hoisting. I'm only mentioning it here just for historical reasons. It's not really an issue anymore, but you may come across the term hoisting and wonder what's that all about. And there you go. Now in ES6 and beyond, we still have function declarations and function expressions. We also have a new way of declaring a function, which is called an arrow function. And we'll look at those, and there's actually a shorthand version of that. So you'll see me using arrow functions quite a lot, and Frank as well later on. Finally, then, as well from day one, we have what are called anonymous functions. An anonymous function is a function that doesn't have a name, which may seem like a fairly odd kind of thing, but we actually use anonymous functions quite a lot, and you will see me using them today. They have been there, as I said, from day one. So just like last week, I'm going to show you all of these different ways of declaring functions by way of samples. So there is a set of samples with this lecture, and you will get them in this week's lab. So if I just import the samples into my VS Code. And we'll use the live server as we did last week. So the routine is, as you know, open up your index.html, and then down at the bottom of in the status bar of the VS Code, you just click on the go live, and that kicks off our HTTP server. Open up your developer tools. Right, and let's go back to the index.html. And again, we have references to various script files, which we will just enable and disable as we talk our way through this. So the first one is referring to this file here. So this is the actual code that's in it. So there's quite a lot in this now. I just packed a lot into it just to, rather than flicking through a number of files. So just for illustration purposes, again, I've got the me JavaScript object. I've got a her object. Both me and her are meant to represent people, Maria. And I've got a here object, which is representing a place. And so here we go in terms of functions. So this is what we refer to as a function declaration. Okay, so keyword function, the name that you want to give to the function, and then the parameters. And it looks like, just based on the name anyway, what this function does is it takes an object and it determines whether that object is representing a person or not. This is just one illustration. And I'm just doing a simple Boolean check here to see, does the object contain a name and a gender? And that's my way of determining whether it is a person object or not. And it just returns the evaluation of all of that. So it returns a Boolean. So from a function declaration point of view, this is what we're interested in: function keyword, name of the function, parameters in parentheses, and then you wrap the body of the function with your curly braces. So we would refer to this area inside here now as the a block, and any variables declared in here are only visible inside this function. This is this block scope idea of variables that we talked about last week. And here then I'm just invoking the function a couple of times. So I'm invoking it once with the me object. So I'd expect that to return a Boolean true, because this will evaluate to true. And then I invoke it with the here object. In that case, it should return a Boolean false, because this part of the here object is going to fail. There is no gender property in my here object. And so to confirm that in the browser, if I go over to the browser, then that's where I'm getting my true and false here. That's function declarations. Function expressions then is where you assign the function to a variable. So that's what's going on here. So I have my keyword function again. I don't give a name to the function here. The name from the function is actually taken from the variable name. And again, from there on, then it's pretty much the same. Your parentheses, or your parameters, sorry, to your function is wrapped in parentheses. Again, it happens to be just only one. Or sorry, there's two in this case. And then the body of the function is wrapped inside your curly braces. Based on the name here, it looks like that what this function does is it expects to receive an object representing a person and a string which represents a middle name that I want to add to that person object. So just for illustration purposes, the first thing I do is I check to see, is the person object really representing a person, as I've outlined earlier? And if it's not, then I'm throwing an exception. So in passing here, I'm showing you how to throw an exception in JavaScript, very similar to Java, I think, in syntax. So assuming that we don't throw an exception, of course, you know that if you throw an exception, then the rest of the function doesn't execute at all. So assuming that it skips over that part, then what I'm doing here is I'm checking to see there's person.name.middle equals undefined. And you might remember from last week, this is really a way of checking to see, does this person object already have a middle name or not? I could have expressed this differently. I could have used the in operator. Either way will work. And so if all of this expression evaluates to true, that means this person does not have a middle name. So all I'm doing is adding a middle name to the object. If it's false, it looks like what I want to do is I want to extend their current middle name, just doing the plus equals there. And you can see from my two sample objects at the top, the me object does not have a middle name, whereas the her object already does have a middle name. So I'm going to be extending the second one and just adding to the first one. And to illustrate, here I'm invoking my add middle name function here and here. Of course, I have to wrap it in a try catch block because I know that there is the possibility that the function will throw an exception. So I just want to catch it, and well, all I'm doing is rethrowing it. That's a very Java thing. Again, I'm assuming I don't have to explain try catch blocks. You've come across them in other contexts. So in the case of this console.log, because I'm passing the me object, then the console.log will generate this here. So there's the middle name added to the me object. And in the case of the second one, where I added the middle name to the her object, then I essentially extend the person's middle name because she already had a middle name property. Now, I should say, I should have said at the beginning, but I said it last week, at any stage, if you want to ask any questions, then just feel free to just butt in. Don't wait for me to invite you to ask questions. And oh yeah, if we take, sorry now. Oh yeah, this line here, I've commented it out because if I enable it, what am I doing? I'm calling add middle name to the here object. And now I could have, doesn't really matter, but if I did actually add in the second argument, not really needed, because based on the way I written my function, because the here object is going to, this condition test here is going to evaluate to true. So it's going to throw the exception because I have a not operator here. And it's going to throw the exception. So if I now save this change, because I've just enabled this new line of code, if I save it, go back to my browser, you can see the exception has been thrown here. So that's in terms of functions, that is function expressions. Again, the general idea is you assign the function, you assign the function to a variable. Now, that's a very powerful thing because anything that we can assign to variables means that we can pass variables around the place. So it means that in JavaScript, I can actually pass a function into another function. And that's a technique that we use quite a lot. Initially, if you're not familiar with that, or if you're not used to it from other languages, it seems a bit peculiar, but it's a very important part of the JavaScript language, which we'll see in a while. But for now, anyway, this is what we call a function expression. Moving on, the next is, okay, let's go back to the slides. So we had function declarations, which was the first one, function expressions, hoisting, okay, that's all right. Next is arrow functions, which was introduced in ES6. And I suppose that in very simple terms, what arrow functions are is just a cleaner form of declaring functions. So here's just a generic example kind of here, right? The keyword function isn't used anymore, but this symbol here, which we call the fat arrow symbol, that's telling me that what's actually happening here is I'm declaring a function and I'm assigning it to a variable. Again, the parameters to the function are enclosed in parentheses. The body of the function is enclosed in curly braces. That hasn't changed. Now, there are some other characteristics associated with arrow functions which were not present in the older forms, function declarations and function expressions. It relates to the binding of what's called this variable I'm kind of ignoring that for now. We may not need to worry about this variable at all, but there are that aspect was actually cleaned up. It was a major kind of source of errors, this variable and the use of this variable within a function, and trying to work out what this variable was actually pointing at in terms of an object. That was a real source of pain for a lot of developers, and that was cleaned up in this arrow function implementation. But as I said, I'm just going to ignore it for now. For now, all we'll say about arrow functions is that they are a cleaner form of declaring functions. By cleaner, I mean just simply less syntax associated with them. So the arrow separates the body from the parameters. And there's a lot of other optional syntax here that you can leave out. So I'm saying, okay, you enclose the body with curly braces, but if the body only has one line of code in it, and that can arise in many cases in our JavaScript code, if the body only has one statement in it, then you can actually leave out the curly braces. And in fact, if the body, similarly with the parameters, if there's only one parameter to your function, then you can leave out the parentheses, the roundy brackets. And even more so, if the body only has a single statement in it, and that statement, when it executes, that represents the return value of the function, then you can actually leave out the keyword return as well. Now, I think when you begin writing JavaScript code using the arrow function representation, you'll probably forget about all of these, and you'll write them in the kind of long-handed way. By that, I mean using the curly braces, using the return keyword, using the parentheses. You'll fall into that habit. But as you do more and more JavaScript coding, you'll get used to actually dropping the optional parts that you don't need. And I wouldn't worry about getting to that level necessarily, if even at the end of this module. It depends on how much JavaScript programming you've done prior to this. So you'll see me writing arrow functions. Sometimes I write them with all of the syntax in them. Other times I write them with some of the syntax missing because I can leave it out. So I even fall into that trap of not remembering that certain parts of the syntax can be omitted for certain cases. Just to go back to the examples then of arrow functions. Here we go. So this function, based on the name, all it's doing is it's returning a string with a salutation to a person object, either preceding the person with Mr. or Mrs. I think is all I do. So again, here's my arrow. So it must be a function that I'm declaring. There's more than one line of code. I'm just going to pause for 1 second now. Just give me a, sorry. Off that. Sorry. What am I doing? I'm checking to see if the parameter that was passed in is a person object, throwing an exception if it's not. And then I am checking to see whether the person their gender is male or female. Just in passing, what you're seeing here is that what's called the ternary operator. This is this question mark. You can get it in other languages as well, so you may have come across it before. The way you kind of interpret what's going on in this line of code here is this expression before the question mark is evaluated. And if it's true, then what follows the question mark immediately follows it. That is what is assigned to the variable on the left. Otherwise, the kind of colon is otherwise. This value here is assigned to the variable on the left. So I'm either assigning Mr. or Miss to my title variable based on an evaluation of this expression. And then I'm just returning a string template. String templates was at the very end of last week's lecture. I don't think I covered them formally with you, but you could nearly work out what's happening. I'll just briefly explain it right now. This is a string template, as I said. And the way we know it's a string template is this, the very beginning of it is, it's not a single quote, this character here, that's actually a back quote, and its closing character is a back quote or back tick as well. And anything inside this template, if it begins with dollar curly brace, open curly brace, then what's inside the curly braces, that's evaluated, and the result of the evaluation is inserted into the overall string. So this string template has some static parts, like hello is static, and that's the only static part actually. The rest then is kind of dynamically computed. This is dynamically computed. This is dynamically computed, and this is dynamically computed. And the result of the computations is inserted into the overall string. This was an example might serve better. So I've got a console.log of salute to me. Now, because me is the gender property was male, then it should come back. This should return hello, Mr. Dermot O'Connor. And I guess that's what I get. Oh dear, I'll just do, did I undo that? I thought I saved that. Sorry, 1 second now. Just undo this. So there we go there. Again, you can go back and look at these in your own time.
Can we give a new line character inside the delegate?
You can, yeah. It's just, I think if you do, let me see. If I do, I can put it anywhere really. I can just say put it in here. I think it's going to be /n. Let's see whether that does it. Yeah. Sorry, did not do it. Yes, you see, did it here.
Yeah.
And the /t is if you want to insert a tab. So they're just escape characters, really. That's all they are. Okay, that's arrow functions. Well, it's our first look at arrow functions. Right, let's move on. Oh yeah, all I'm showing you here is arrow functions are converted back into ES5 type functions behind the scenes. So if what we often say is that the syntax associated with arrow functions, they are syntactic sugar. They've just been added just to make life easier for the developer. But at runtime, they need to be, sorry, not at runtime, but they need to be converted back to the older ES5 syntax if we want to guarantee that the code can actually run in the browser, in particular in older browsers. Newer browsers will probably recognize the arrow function syntax, but older browsers don't. And so we do need to convert it back. So the question might arise, well, what does an arrow function look like when we convert it back? And all I'm showing you here is a screenshot from a website that it may be useful. It's this one here, babelJS.io. What this allows you to do, amongst other things, is it allows you to insert modern JavaScript code on the left, and it will convert it to its equivalent ES5 syntax on the right. So just to give you an idea. So it's just a kind of it's a playground really for developing an understanding of modern JavaScript. So if I just do that, for example, if I take my arrow function, which is here, and I just copy it into on the left, then you can see the equivalent on the right. And so, not surprisingly, it's a function expression, sorry, is what it evaluates to. And somebody was asking me about the var keyword last week. Well, var was the old way of declaring a variable. So var is the old equivalent to either const or let. So that's what it actually, it wouldn't be difficult to have worked that out now, but there you go. So that's all that's the only purpose that this slide is serving, just to make you aware of that website. Some other characteristics of functions. I'm only mentioning this slide here for completeness. Again, it's not something I'm pretty certain we will need to avail of, but there are what are called constructor functions available to us in the language, and they have been there from day one. And the short explanation is that constructor functions serve the exact same purpose as constructor methods in conventional object-oriented languages. I'm assuming you know what I mean by a constructor method in, let's say, a Java class or a C# class. It's for creating an instance of that class. Well, constructor functions serve the same purpose in JavaScript. And as I said, they have been there from day one. The way we use them is slightly different to the way I've been using functions so far. So let's supposing the way we kind of declare them is the same as before. We typically use function declaration syntax for declaring these constructor functions. We also, by convention, tend to capitalize the function name, whereas any of the samples I've shown you so far, I was using camel case as my convention, but that's just a convention. The convention for constructor functions is to capitalize the function name. That kind of tells the reader this function is really serving the purpose of being a constructor. It takes parameters and then it has a body. Typically inside in the body, what you will be doing is creating a blank object and then populating that object with various key value pairs, typically based on whatever is passed in here. So you're kind of constructing an object instance. The way you invoke the function is very different to before. You actually precede the function name with new, and that's a bit like new as in Java or C#. So overall, what this line here is doing is it's creating a new person object, and I'm assigning it to a variable. So as I said, it serves the exact same purpose as classes in Java. So that's just constructor functions. You may come across them when you're reading about JavaScript. As I said, we won't be using them. They probably are being used behind the scenes in any third-party libraries that we will be using, but we don't need to use them directly ourselves. Completely separate from all of that is this notion of side effects. This is a kind of a general programming idea. When we talk about a method or a function having a side effect, what we mean is that the function or method modifies some data outside of its own scope. Now, to express that in pure JavaScript terms, we would say that a function that has a side effect is a function that modifies some object that has been declared outside of its own scope. Okay, so for example, the add middle name function that I had there a few moments ago, we would say that that causes side effects because the person object, whether that was me or her, they were actually declared outside of the function. They were passed into it, okay, and then within the function, it was actually changing them. So the function, we would say, it has side effects. The salute function, if you can remember, that did not cause any changes to the person object that was passed into it. So we would say that the salute method did not have any side effects. By convention, any function that performs IO, we would say that that has side effects as well. So it's not just necessarily changing data outside of its scope. If it causes anything to happen outside of its scope, and clearly IO is something that happens outside the scope of a function, then such a function, we would say, has side effects. The opposite of a function that has side effects is a pure function. A pure function never causes any changes outside of its own scope. And ideally, we would like to maximize the number of pure functions in our code. There is an area of programming called functional programming. And functional programming, its main thrust is to maximize the amount of pure functions or methods within an overall application. So it's really a kind of a programming paradigm, this functional programming. We won't necessarily try and follow it, but I'm just making you aware of these terms, which you may have come across already in other programming contexts. So the next thing I want to talk about are, sorry, I skipped the slide there. This is the next slide. Higher order functions. A higher order function is a function that takes a function as a parameter, and or it returns a function as its return value. And we see higher order functions used all over the place in our code. So we need to get familiar with or be comfortable, I suppose, with the syntax. So any function that takes a function as a parameter, we would classify that as a higher order function. The function that's being passed in as a parameter, we refer to as a callback. And really all that's happening is that the callback is invoked or called somewhere within the body of the function that is receiving the callback as a parameter. So in very general kind of terms, I'm using function declarations here, but we could use either of the styles that we've seen so far. So I've got some function, it has a number of parameters, but one of them is actually one of its parameters is a function as well. And okay, so the callback usually, at this stage now in 2022, and really from kind of 2016 onwards, we tend to implement the callbacks using the using the arrow function style, but we also use the anonymous function style for declaring these callbacks. Now, I haven't covered anonymous functions so far with you, but we'll see them in a moment. Now, to explain or demonstrate higher order functions, I'm actually going to use a series of methods that are associated with the array type that we mentioned last week. And they're just a case study really on higher order functions. I could have picked any other case study, but this is a nice compact little illustration of higher order functions. And also we'll actually see these methods as we work our way through this module, as it turns out. So there are probably more actually, but there are 4 methods associated with an array structure. And each of these methods follow this higher order function characteristic. I tend to use the word method and function interchangeably because really functions and methods are one and the same thing. The difference is, as you know, a method is really a function associated with a particular object instance. Okay, so the simplest one is the for each method, and I'm giving you kind of the overall kind of code, how it kind of flows in this slide here. So let's supposing I declare an array of something. It doesn't really matter what the specifics entries in the array are. And then I'm on that array, I'm invoking the for each method. So I'm using the kind of dot syntax, which we're familiar with from any object-oriented language that you've seen before now. And the for each takes one parameter, and the parameter is a callback. And we can see it here. Here's this function here is a parameter to this method. So what the for each does is it invokes this function here once for each element in the source array. And for each invocation of this callback function, what for each will do is it will pass the current element in the array that it wants processed. It'll pass the index position of that element, and it'll actually pass it the entire array as well, should the function need it, should the callback need it. And then these curly braces here now are wrapping the body of my callback. Note this function here, it doesn't have a name. Hence, I'm referring to it as an anonymous function. An anonymous function is a function with no name, and indeed, that's what this function lacks. So, and again, the syntax can be a little bit off-putting. So the curly brace here terminates my callback function, and the parentheses, the parentheses here is closing this parenthesis here. So my anonymous function is the callback, is called, as I said, for each entry in the array. And really what for each is just an alternative to using a for loop. So we don't tend to use for loops when we're iterating over arrays in JavaScript. We tend to use the for each instead. It's just a kind of idiom of the language, if you like. The final point I'm making is that we tend to use arrow functions rather than this function declaration syntax. We tend to use the arrow function syntax for this higher order function case. And I think I have an example in the code. Do I have an example? Yeah, here we go. So I've just got an array of numbers, and then I'm calling for each on my numbers array. And here's my anonymous function implemented using the arrow syntax. It's not doing anything interesting. All it's doing is a console.log of the element itself and telling us what position it's at. So again, so in the case of the for each, the callback is past a reference. So E is a reference to the current element in the array that's being processed. Index is, as I said, an array is the actual full array itself. So this overall piece of code here generates this output here. And again, you can look at that yourselves later on if you need to. I have another example here, and all I'm doing here is I'm trying to calculate how many of the numbers in my array are even numbers, I think. Okay, so I declare that first to be initialize it to 0, and then I iterate over my array using the for each. Here's my arrow function, and I'm just doing a computation. Now, there's a lot of stuff going on here, but this is the kind of shorthand version of the arrow function. I don't have any curly braces. Like the long-handed way of writing this piece of code would be to do that and move that up and stick the return keyword in front of it. And now it's looks kind of more familiar to you, I guess, if you haven't used arrow functions before. But because there's only one statement in the body of this arrow function, and the evaluation of that return statement is the return value for the return value. Sorry, just checking one thing now. Oh yeah, is the return value. Then, well, strictly speaking, I suppose it doesn't have a return value. The for each doesn't have a return value. I'm just changing nums. I'm incrementing it by either 0 or 1, depending on whether it's an even number or not. But either way, because there's only a single statement in the body of my arrow function, then I can get rid of all that extra syntax as I had it originally. Back to here. And indeed, you know, I could actually have gotten rid of those as well, because when there's only a single parameter to your arrow function, you can leave out the parentheses. Probably gets a little bit too difficult to interpret when you do that. So I tend to leave them in, but it's a matter of style. as I said a few moments ago, it may take you a little bit of time to get used to reading this code when we're using arrow functions, and certainly when we're using arrow functions as callbacks to higher order functions. But you get used to it after a while. There is a gotcha. And the gotcha is if you accidentally put in a colon there, you might think, well, that shouldn't really cause any issues, but in fact it is. If I now save that change, it's actually telling me you've got a syntax error in your code. The reason for that is the interpreter is interpreting the colon here as the end of this statement. Sorry, as the end of this entire statement. But it can't be the end of it because I've got an open parenthesis here and I don't have any closing parentheses. If I simply stick the closing parenthesis here before it, now it's going to be happy. Of course, I have to get rid of this one here. So just be careful. It's probably going to catch you out if you write arrow functions and the arrow function happens to be a callback and it's the shorthand version. Just be careful about putting a semicolon at the end of the arrow function declaration. It is going to cause problems. If you're slightly unclear about that now, I'm not that surprised, but it is a kind of a gotcha, really. Ask a question if you want to, but otherwise I'll just move on. So in general, anyway, we're talking about higher order functions, and the first example we've seen out of it is the array for each method, which takes a callback as its argument. Now, if I go back one slide, so that's for each. Then we look at these three other ones as well, and they're slightly more involved. Now, to demonstrate the other three methods, filter, map, and reduce, I've set up a little example which may seem overly complicated, but there's a reason why I've done this. So if I can just explain, first of all, how the remaining examples are actually designed from kind of an architecture point of view. This is what I've actually got for each of the remaining samples that we're going to look at now. Each of these samples has the following setup associated with it. I first of all have the live server running. And the live server is, as we've talked about before, what it is actually doing is it's passing your HTML index.html down to my browser and any associated JavaScript. Now, the JavaScript in this case, for the examples I'm going to look at in a moment, the JavaScript will involve demonstrating the filter, map, and reduce higher order methods associated with the array type. What the JavaScript code also will do actually is it's going to make a HTTP request to a web API called the Random User Web API. And this web API, all it does is it generates user profile objects, and it'll generate as many of them as you've asked it to. It just generates them randomly. Each user profile object has a predefined set of properties, like usual ones: name, address, email, etc., etc. And it will return the array of objects back to you. And then the JavaScript code here is going to process that array. So I have one example where it filters the array, another example where it maps over the array, and a third example where it does something called it reduces the array. So this is the kind of the architecture of the samples that I'm going to look at from here on in. So the Random User API, it's a web API. That's its URL there at the top. And all you've got to do is, if you send it a HTTP request, something like this, for example, where here we've got a query string at the end, and the query string is set to results equals 10. What that is telling the Random User Web API is to generate 10 user profiles and send them back to me as your HTTP response. And it sends them back in JSON form. And we don't have to worry about that. We can unpack the JSON and convert it into an ordinary JavaScript array of objects, which is really what we want. Now, let's see a simple demonstration of this whole setup, first of all. So I'm no longer interested now in this 0 functions. So I'm just going to undo any changes. We look at this script first of all. And here is the script here. Now, in general, what's going on here is I am making a HTTP request to my random user web API. And I'm taking, in this case, I'm asking it for 6 user profile objects. And I'm just going to call for each on those user profiles. And I'm just doing a console.log of some information associated with each of the users. Okay, and it's outputting here the 6 randomly generated user that it created. Every time I invoke it, because if I do a manual refresh here, you know, it's a different set of users every time, because as I said, it dynamically and randomly generates these user profile objects. So if I take it from the top down, so fetch here is a function that's built into all browsers now. And what the fetch function allows me to do is to make a HTTP request from within your browser. I'm making the HTTP request to this particular URL, which happens to be the URL associated with a web API. In other words, the URL will respond not with HTML, but it will respond with some JSON data. And I've already told you what that JSON data is going to be. Now, the way you need to, this code here from kind of here up, this code is kind of, is boilerplate, but what's happening on this line here is, well, sorry, first of all, the fetch function is our first example of a function that is asynchronous in nature. By that, I mean that the response back from the function is not going to happen immediately or synchronously. It's going to happen asynchronously. It's going to happen sometime in the future. We don't know exactly when the response is going to come back. And so the way we handle the response is going to be different for an asynchronous function as opposed to a synchronous function. And we're using what's referred to as a promises programming style here. We will cover the promises programming model later on in this module. For now, we just need to accept the syntax that I'm giving you here as just kind of boilerplate. So what I mean by that is when eventually the API responds back with the data, the next thing that's going to happen is this callback is going to be invoked, because what I'm actually doing here is I'm calling a method called then, and the then method is associated with whatever fetch returns. Now, when I say what fetch returns, it's not what's returned by the web API, it's what the actual fetch function itself returns back to my code. What it returns technically is what's referred to as a promise object. When the actual response comes back from the web API, the way the then method works is it will invoke this callback when the response comes back from the web API. In general, web APIs may not, it may actually fragment the response that it sends back to us. And therefore, in other words, it may send back a stream. The response may be a stream, and that stream needs to be reassembled in my browser. And really, that's what this is doing. It's reassembling the streamed and fragmented response that may have come back from the web API. And when all of the stream and fragments have been reassembled, only then, and again, that is also going to be asynchronous, only when that has happened will this then method be invoked. And this then method also takes a callback. And here's my callback, begins, sorry, my callback is here. And really, it's this callback that I've highlighted now. That's the one we're really interested in. I think for now, if you're not familiar with promises, which I don't expect you to be, you should interpret all of this code here as just boilerplate. Now, the only thing that's going to change from web API to web API is whatever the URL of the web API is. This line here is boilerplate, and this part here is boilerplate. What's going to change as well is what is the body of the callback that you pass to the second then method. For this second callback, this argument here, response body, as its name kind of suggests, that is going to have the body of the HTTP response that comes back from my web API. Now, you would have had to examine the documentation associated with the web API, but I can tell you that in the body of the response, in fact, what I'll do is if I do a console.log, and that's really the easy way to find out if you're not already familiar with the web API. That's how you find out, well, what is the actual structure of the response that came back from the web API? So if I do response body and save that, go back to my browser. And here's the full body of the response that came back from this particular web API. And if we drill down into it, there's well, originally it was JSON, and the JSON was converted into a JavaScript object. Sorry now for flicking around, but the conversion from JSON to a JavaScript object was taken care of, you might have guessed it, was taken care of by that line for us automatically. So ultimately when we get to this stage here, response body is going to be a JavaScript object, which is what we like. And for this particular web API, this is the structure of the JavaScript object. And the part that we're really interested in is the results key. If I expand that, that's where my actual user objects, and I can now get a sense of what the structure of a user profile or user object is from this particular web API. So when I go and take out that line again, so from this line here, when I go response body dot results, we now know that that expression evaluates to an array. So profiles finally is the array that I actually want to process. And all I'm doing in this case, in this illustration, is just invoking for each on it, which I've already spoken about. And I'm just doing a console.log and constructing a string template. Okay, so the important parts in this piece of code is the role of the fetch, and as I'm calling it, just this boilerplate code. You just take it and copy and paste it anytime you want to use this web API. And then the rest, the second then method, the callback that you pass to it, will be specific to whatever you want to do with the actual data that comes back. So now I want to talk about filter and map and reduce, those methods associated with the array. And I'm going to use this, this little case study as a way of explaining those, higher order methods. Just pause for a second in case there's any questions related to this. No, Postman, I won't talk about Postman now, it's not relevant, but we'll actually use Postman later on in the semester. Okay, so back to arrays, higher order functions, and I've just talked my way through what I'm calling the base example. And again, sorry now for flicking around the place, but the base example, it had actually this structure, okay? I had my web API, I had my JavaScript code in the browser, and of course my live server is running in the background as well. So it does actually match this diagram that I'm showing you. The example that I've just talked my way through matches this, this structure or this architecture, I guess, if you like. Right, let's talk about filter. So filter is also a method associated with the array type, and it takes a callback. But what filter does is it invokes the callback for each entry in my array. And if the callback returns a Boolean true, then it adds that element of the array to a new array. It doesn't remove it from the original array, but it will make a copy of it, if you like, and add it to a new array. So as its name suggests, what filter does is it filters your source array and creates a subset of that source array. Sometimes the subset has nothing in it because none of the entries in the source array satisfy the callbacks requirements or somewhere in between. It might have all the entries or somewhere in between that. So what it does is it selects entries from your source array based on some sort of criteria, and the criteria is expressed in the callback. The selected entries are added to a new array, as I said, so it doesn't actually change your source array. Hence, we would say that it's an example of a pure method stroke function. Filter is a pure method, doesn't change the source array. And we're told to look at this sample as an illustration of filter being used. So let's do that. And here's the code. So again, start of it is as before. So hopefully I don't need to talk through that. And so we pick up the story really from here down. Okay, the first thing I want to do is, you can see from this line here, my objective is to find all female users in the array of profiles. Now, if I didn't know anything about filter, I would probably use some sort of for loop to do that. And that's really all I'm showing you here. So that would be the old style of achieving this objective. But of course, we're not going to do that. We're going to use filter instead. So here we go. So profiles is my array of user profiles. Here's my filter method. And here's the callback that I'm passing to it. And just like for each, the callback for filter takes, well, it can take actually up to 4 arguments, but sometimes you don't need all 4 of them. So the first argument is going to be a reference to the current array entry that you're processing. This is obviously going to, the second argument is going to be the index position of that. Now, as it turns out, I don't need the index position because I don't use it. So I could have left that out. By the way, in passing, JavaScript supports variable parameter lists. By that, I mean, sometimes you might invoke a function where you give it all the parameters. Other times you might invoke it where you only give it some of the parameters. And it depends on what the body requires. So I've just included index here, even though it's not actually used. I could take that out. It's not going to break anything. You don't have to pass it all the arguments that it requires if it just doesn't use them. And in the body, what am I doing? So again, just trying to remember now that the callback for the callback function for the filter method, it has to return a Boolean. and the Boolean determines whether the particular entry in the array that's being processed should be included in the output array or not. This is my output array in this case. And so you can tell that what I'm doing is I'm just checking the profile.gender to see if it's equal to this value here. And if it is, then I know that person is female. And so if that expression evaluates to true, then whatever user we're currently processing, a copy of that object, well, strictly not a copy, it's just a reference to that object, will be added to my new output array. And I'm console.logging that. So if I look at the browser, it seems like, sorry, now if I go back again, yeah, so I output the full array just to help us understand. I output the full array here, and the second console.log is only outputting the female entries within that array. And you can check that for yourselves. If you expand, here's my full array, check to see how many of them are female and which ones are female, and then that should correspond to this array here. And you can see all of the profiles are female in this array. So it looks like it's working properly. That's one example of filter. Here's a second example. In this example, my objective is to find all males that are less than 40 years old. So again, you know, same kind of pattern as before. Here's the body of my, here's my callback using the arrow syntax. And because the body of my callback is a single statement, and that is its return value, then I've dropped a lot of the optional syntax. There's no curly braces being used here. There's no return keyword. You know, I did use the return keyword up here. I did use the explicit curly brace here, whereas I'm not using it down here. But it all still works fine. And again, you know, the mistake might be, you know, if you put a semicolon, sorry, here at the end, that's going to break the code as I explained before. But apart from that, this is just another illustration of filter being used. And that's it, I think, just two examples. The reason I have a catch block here is the catch is associated with the fetch, because the fetch could throw an exception. For example, if the URL if it's an invalid URL, if it comes back with an error response saying, you know, the URL doesn't exist or whatever, the network is down, etc. The fetch will throw an exception. I think the this then might throw an exception as well. But that's where the catch is linked with the HTTP communication, if you like. Just pause for a second in case there are any questions. I'm going through this at a reasonably fast pace. No, that's filter. The map, whereas filter returns a subset of your source array, map will return an array that has the same number of entries as the source array. But typically what you use map to do is to take your source array and create an output array containing objects where the objects in that output array are kind of a subset of the source objects themselves. You know, they contain less information than the source objects. So again, it has the exact same signature though. It just takes one argument, which is a callback. And what the callback does in this case is it constructs the objects that you want to put into the output array. So it creates a new array as before, and it's based on the source array, and there's a one-to-one. So as I said, however many entries you had in the source array, you're going to have the same number of entries in your output array for map. It does not change the source array, hence it's also a pure method. And we've got an example to demonstrate. Now, in this case, let's see, my first objective is just to create an array of objects where the objects just contains a person's name and their email address. Is that right? Yeah. Okay. So that's the objective. Again, if I didn't know anything about the map method, I could use a for loop to do that for me. And that's what I'm showing you here. But map achieves the same in a lot less code. So here's my invocation of map, and here's my callback. Just create enter space, just to make it a little bit easier. Again, the callback takes, it actually takes 3 parameters as well, but I'm only using the first of those 3, so I don't need the rest of them. And in the body, I am indeed, looks like I am constructing an object and I'm returning that object. So this object here that I've highlighted, that is the structure of the objects that will be inside in my output array. And when I do my console.log, what I get is, so there are, in this case, there are 10 objects in the source array, and there are also 10 objects in my output array. And indeed, they have the structure that I require, just the name and email. We've got a second example where my objective is just to create an array containing the ages of each of the users. So that's just going to be an array of integers. And you can see that the callback that I'm passing to map here is just returning an integer value. So it's not actually returning an object at all. It's just returning a primitive, but that's fine. And if I look to see what does that look like. Yeah, here's my array of primitives. Finally, we have the reduce method. And it's also a higher order method stroke function, but it's a little bit trickier now than the 2 that we've looked at so far. So reduce also takes a callback, and that callback is invoked once for each member of the array. Reduce takes a second argument as well. Now, what the purpose of reduce is to compute some sort of accumulator associated with your source array. That's what we're saying here. It reduces the source array to a single accumulator value, or it computes an accumulator value for your source array. Again, it doesn't change the source array. Now, accumulator, we've kind of heard of that term before, but it turns out now that accumulator has a much broader meaning than the conventional sense of what we might term an accumulator to be. And maybe examples will illustrate what I mean by that. But that's its overall purpose. It is to compute this single accumulator value, where value really here could be a primitive, it could be an object, it could be an array, it could be any kind of structure that you want it to be. And the way in general that the reduce method works is, if I go back up to my code here, it calls this callback once for each entry in the array. In this case, though, the callback, its very first argument or parameter is the current accumulator value. The second argument is the current entry in the array that's being processed, and the other arguments are as before. What the body of the callback is going to do is it is going to update the accumulator that has been passed to it, and it returns the updated accumulated computation. It has to return this. And the reason it has to return it is because the next invocation of the callback by reduce is going to take whatever was returned by the previous invocation of the callback, and it makes that the first parameter of the subsequent invocation of the callback. So if you like, it's being passed. The accumulator is being computed and updated every time, and it's being passed between invocations of the callback. What this here is the initial value for my accumulator when the reduce method calls the callback for the first time. In other words, for the first entry in the array. What is the initial value that I want to give the accumulator? And choosing the right initial value is critical to getting the reduce to work properly for you. Right, let's see this in action. So picking up the story from here, I'm outputting my full array of profiles as before. That's just to help us understand what's going on. So my first objective is to compute the average age of all of the users. So this is a classic example of what an accumulator might be. Now, to compute the average age of all of your user profiles, obviously what you've got to do is, first of all, compute the total ages. That's really our accumulator in this case, and then divide that by the number of users in the profiles, in the array of profiles. So I'm going to use the reduce method to compute the total of all of my users' ages. And then I'll do a simple division outside of the reduce. So here we go, profiles.reduce, and here's my callback that I pass to reduce. And it takes total here now is going to be the total age of all of the users that have been processed so far. And inside in the body, all I'm doing is I'm taking total and I'm adding to it the current user's age to that total, and I'm returning that. And obviously the initial value from my accumulator is going to be 0. So that's the simplest example of reduce being used. And the accumulator in this case is what we would conventionally understand an accumulator to be. We're accumulating the ages into a single value. And then I'm just in the console.log, I'm just doing the division by the number of users to get the average. So I don't think I need to explain that in any more detail, just make sure it's working out okay. So if you wanted to, you can expand this, go down, find the ages of each of the members, and hopefully when you compute the average, you're going to get something like what's being outputted here. The next illustration of reduce being used, my objective is I want to find the youngest user in my array of user profiles. Reduce wouldn't pop into your head as perhaps the way of approaching that, but reduce is the right solution or the right approach to the solution for this. So in this case, my callback, what it needs to do essentially is it needs to determine, is the current user that's being processed, is that user's age less than any of the ages that I've seen so far or that has been processed so far? If it is, make that the new youngest age. If it's not, then leave the youngest age to be whatever it was before this particular invocation of the callback. And so in the body, what I'm doing is I'm passing into my callback, I'm passing it in the minimum age that has been found so far, and I'm passing in the user profile. And you can see from the code, I mean, you can read it yourself. Here, I'm just doing a simple check to see is the person's age, is it less than the current minimum? Again, I'm using my ternary operator. So if that entire expression evaluates to true, then I'm taking the person's age and I'm assigning that to this new min variable. Otherwise, I'm assigning the current min that was passed into me as my new min, and I'm returning new min. And new min is now going to be bound to min for the next invocation of my callback for the next user. The important decision to make is, what do I set the initial value of my minimum age to be so that this is going to work? Now, if you set that to 0, then it's not going to work because nobody is going to have an age less than 0. So my reduce is going to return 0 as being the minimum age. However, by setting the minimum age to something that's high enough, 100 is certainly high enough, then you're bound to find at least one person, if not more, if not everybody, that has a minimum age, that has an age less than 100. So getting the initial value right is important to when you're using reduce. The third example is even more involved. The third example, my objective is to create this object here. And within the object, I want to have I want to group my users into their age groups. And I've just decided arbitrarily that my age groups are less than 25, between 25 and 50, and so on up. These are my 4 age groups. And I want the values associated with these keys in my object to correspond to how many users in my array are in each of the categories. So from a reduce point of view, this is my initial accumulator value. It's an object, but it's, it's a single value. And then what the reduce callback will do is it will update this structure. It'll add 1 to the relevant key within this object based on the person's age. I've also got a simple little convenience function. Well, sorry, what I'm doing here is I'm first of all extracting all of the keys from the object above here. Okay, so there's quite a bit going on here. I am creating a convenience function for myself, utility function, which is going to be passed in somebody's age. It's going to be passed in an integer, which is somebody's age, and it's going to return the relevant entry in my array of keys. So if the person's age was 55, then it would return this one here. We return this here. And subscript 2 refers to this entry here, for example. Sorry, well, it refers to that key, but it would refer to the third entry in this array. So that's kind of all set up for myself to make my reduce a little bit easier to program. And here's my actual invocation of the reduce. So I'm passing it in as the initial value from my accumulator. I'm passing it in the object that I created up here. And then inside in the callback method itself, I am, I'm playing around with finding the person's age, getting their age, finding which of the keys within my accumulator object should I increment, and then I increment that the value associated with that key, and then I return my updated accumulator, my updated instance of this object up here. So you'd need a little bit of time to study that, I think, to fully grasp how I approach that. And I'll let you do that in your own time. Right, so that was by way of illustrating this notion of higher order functions. And again, we just used a particular case study to demonstrate them, but we'll see higher order functions all over our code base. So in summary, that's fine. Functions, we have function declarations, function expressions, arrow functions, shorthanded version of the arrow functions, anonymous functions, which we've seen a lot of there now. Every one of the callbacks that we pass to our higher order functions would be referred to as anonymous functions. And we happen to program our anonymous functions using the arrow function syntax, but we could just as easily have used the function declaration syntax. By that, I mean, you know, if I take any one of them really, if I just take, let's say this one, I could have went here, function, and get rid of the arrow symbol. Do that. And sorry, was there one there already? There was actually. And close it off. Sorry, that closes that, so that's okay. Yeah, I think that's it really. That's the function declaration syntax, but again, it's an anonymous function because, you know, the callback doesn't actually have a name. And we talked about higher order functions. Okay. Now, based on that coverage, you should now be in a position in your own time to tackle this lab here. And in it, we use another web API called the JSON placeholder, I think, but I explain it in the lab anyway. But we're doing similar kind of things. This other API returns an array of, I think, an array of to-dos, and we process the array of to-dos based on whatever I ask you to extract from the array. Now, if I go back to the overall structure, the next card is this one here, and that's what I'm going to talk about next. I wasn't sure whether I'd get to it or not, but it looks like I've got some good bit of time on my hands, so that's good. I hope I didn't rush through the previous section out too quickly for you, but work your way through the lab, and you may have questions as you're working your way through the lab. So what I want to talk about next is, we've kind of covered now what I'm kind of referring to as the foundations for the rest of this module, that just being JavaScript. We assume that you are familiar with HTML and CSS, and if it's a while since you've done any, then it may be beneficial just to brush up on your knowledge of HTML and CSS. So I want to talk about a little bit about the actual web browser itself. And there's a particular aspect of the web browser that we need to be aware of. Now, there's no slides, sorry, there's no lab associated with this section. There is a little archive. It's not that significant. Whenever you see this symbol in the card, you just click on it and it'll download a zip file and you unzip it. And typically I use the contents of that archive within my lecture, and that's what you'll see in this section. So the slides anyway are these slides. This keeps happening to me. How do I get out of this? Sorry, no. Obviously, with a module like this, we are going to be using the browser is kind of our execution environment, certainly for the stuff that I cover with G. And we need to have some familiarity with that environment as a kind of a programming environment. Right, so the web browser I'm saying is an event-driven environment. First of all, what I'm showing you here is, in very simple terms, I'm kind of explaining how a web browser actually works. By the way, this slide, I'm taking it from a set of slides from a presentation made by a guy called Douglas Crockford. I'm mentioning him there on the top right-hand corner. If you do any kind of Googling on Douglas Crockford video, you'll come across really good presentations that he makes about web development in general. They're always kind of interesting and humorous as well, in fairness. So this slide actually is from a presentation that he gave a number of years ago, admittedly, but fundamentally the browser hasn't changed. So what the picture is telling us is it's explaining how a browser works from the time you change the URL in the browser. Now, whether you change the URL by physically typing a new URL into the browser, or if you click on a hyperlink, which will cause the browser's URL address to change, either way, you have changed the URL address in the browser. And so what the browser does is, it goes into what we call its fetch mode. And in its fetch mode, it makes the HTTP request to the particular server that was referenced in the new URL that was entered. Eventually, we've seen kind of fetch there in our examples, but in the examples that we were using, the fetch was expecting JSON as a response, whereas normally what the browser expects in the response from a fetch is it expects a HTML page to come back in the response, perhaps followed by other assets. So either way, the browser goes into its fetch mode. Eventually, it will get back the response, and the response is, as I just said, it's going to be a HTML page, perhaps followed by some assets being images, maybe even some JavaScript code. Having received all of that, the browser then goes into its parse mode or parse stage. And in the parse stage, what it does is it takes the HTML document and it converts that into something called the DOM. DOM stands for Document Object Model. And what the DOM is an object, a network, a hierarchy of objects, JavaScript objects, which is a JavaScript object representation of the actual HTML. So the DOM is a hierarchical JavaScript object data structure, and it is an internal representation of the HTML. Then the browser goes into its flow mode or flow stage, where it takes the DOM object structure and it analyzes that, and it produces an intermediate representation of that, which we don't really care about. We do care about the DOM, but we don't care about this intermediate one. And it's this intermediate representation of the DOM, which is really also a representation of the actual HTML page itself, then takes that structure, which I'm just calling here the display tree, maybe called something else by other authors, and it enters the paint phase of this processing cycle. And in the paint phase, it actually paints the pixels on the screen. If the browser's URL changes again, then it goes back and starts all over again. Once it's painted the pixels on the screen, essentially then what the browser does is it enters this cycle of phases. The assumption here now is that the browser's URL is not changing at all in this cycle. If it does change, then we go back to the previous slide and it goes through a different process. So our page is now being displayed on the screen, and the browser essentially goes through this cycle of phases that I'm showing you here. And really, the cycle kind of begins here, because it's not obvious from the diagram where does the cycle begin, but it actually begins here. And what happens is typically the user will interact with the page. The interaction may be moving the mouse, clicking on something, entering something on a text box. Any of those interactions by the user on the page will cause the browser to fire an event. It will represent the user's action as an event internally, where an event is just an object, another JavaScript object that the browser actually creates on the fly. So it creates an event representing how the user has interacted with the page. And what we can do as developers is we can write JavaScript functions and associate that JavaScript function with the event. And I'll show you in a few moments how you make that association. But let's supposing we do have some JavaScript functions which were actually downloaded with the page initially, but were not executed. And in the JavaScript code, we associated those functions with certain browser events. And so we formed this link here. Eventually, when one of those events does occur, what the browser will do is it will execute the particular function that we associated with the event. Again, the browser takes care of that for us. That function can do anything we want it to do, but if the function happens to change the DOM data structure, because the DOM now is just a network of JavaScript objects, and we know how to write JavaScript code that can manipulate a JavaScript object structure. If it happens to change the DOM structure, the browser will know that DOM has changed, and it will re-enter the flow phase, which we saw from the previous screen. And what happens in the flow phase? Well, it analyzes, in this case, it would reanalyze the DOM, create a new intermediate representation of that DOM, or display tree, and repaint the screen or part of it, depending on what part of the DOM has actually changed. So we have this kind of cycle of user interacts with page, browser creates an event object corresponding to that interaction, browser executes a particular function that we have written and associated with that action. Of course, if there are no functions, then the event just disappears and nothing happens. Our function, what we call an event handler, executes. It can do anything it wants to. It may even make a HTTP request looking for data. But if the function that we've written happens to change the DOM structure, then automatically the browser will start its flow phase. The browser knows whether you have manipulated or whether some change has happened to the DOM or not. Hence, what we've got is a web page that is dynamic. User interacts with the web page and the web page changes. That's your classic explanation of what a dynamic web page is. The URL in the browser has not changed, but what the user sees on the screen does change. What I'm showing you here is a kind of representation comparing HTML with this DOM structure. So on the right, I have a simple HTML syntax. And on the left, we have there or thereabouts anyway, an excerpt from this DOM data structure that the browser creates from that HTML. And it is, as I said, it is a hierarchy of JavaScript objects. So each of these boxes represents a JavaScript object. In most cases, we don't care about the internals of the object, but it's created them anyway. So for example, the body object in this hierarchy will kind of correspond to the body tag in your HTML. And clearly from here down, the objects do somehow reflect the structure of the HTML. You know, the body has a H1 element and then a paragraph and then a H2 and then another paragraph. And that's exactly mirroring the structure of my HTML. Is it H1 paragraph? The indentation there is slightly misleading because the paragraph really is at the same level as the H1. It's not internal to it. So that's slightly misleading. Now the indentation is wrong there. The H2 and the H1 are at the same level. Yeah. So the indentation there is incorrect, sorry. How do we actually, so this is a network of JavaScript objects. Can we actually access that? And the answer is yes, or how do we do it? Well, what the browser does is it creates a special variable called document. And this variable is pointing at this object. So if you write an expression like document element, you know, what you can actually do is you can navigate from here. You can navigate down to any of these subordinate objects. So there are these kind of pointers set up automatically by the browser when it constructs the DOM, i.e. when the initial HTML page arrives in the browser and it constructs the DOM. It adds in all of these additional navigation pointers between the DOM nodes. We refer to each of these boxes as a node. And again, as I said, the node corresponds to a JavaScript object. So there are various ways of navigating. You can navigate from parent to child. You can navigate from sibling to sibling and backwards. You can navigate from child back to parent. So you can really navigate in any direction that you want to. Really, the most important ones are going from parent to child and going from sibling to sibling. In this slide, I'm showing you on the right a HTML page, which in this case, I think the indentation is correct. And on the left is just the what that displays on the screen. So there's nothing too interesting there. Here, what I'm showing you is you can actually kind of play with the DOM from within the developer tools that comes with the browser. And so if I just do a quick example of that. So, sorry. So the example that I'm going to look at now, the code that I'm going to look at is associated with this archive here. Pull that into VS Code as before. Now I've got two HTML pages, so there's a whole lot to demonstrate here. I'm sorry, I've got more than that. Sorry, I'm just starting it again. Yeah, I've got a couple of them. Either way, let's open up this one here, which is the one I showed you on these slides. And let's start our Go Live server again. Right, so, and let's open up our developer tools. Now, what the slide is kind of trying to explain to us is you can actually, first of all, you know, when you have in the console, when you're in the console tab of your developer tools, you can actually write JavaScript code here. So I can do something like, you know, let x equals 10. You know, I can write any JavaScript code that I want to, and it will execute that. Undefined is just the return value of this expression, right? It doesn't really, it's not relevant here. So you can write JavaScript code here to do anything that you want to. And so you can, for example, you can play with the DOM, and that's what I'm doing on this slide here. So if I type in this expression document, and we know document refers to the top node in our DOM data structure. If I go document.body, that first element child, let's see what that returns back to us. And this is standard object dot notation that we talked about last week. So really what I'm doing here is I am typing in an expression that will navigate down through the DOM data structure. And you can see on the left, actually, it's kind of nice. It's telling us the expression that I've typed so far is telling us that it's actually, you know, it's highlighting the part of the DOM, or I did there for a minute, that is being referenced by the expression. So this entire expression here now that I've typed is referring to a particular node. And if I hit return, lo and behold, it returns back in HTML form, which is kind of convenient. It returns back the part of the page on the left that this expression evaluates to. Now, this expression, like, okay, it's giving us back the HTML, but that's only a convenience. Really, this expression here is referring to a node within my DOM structure. And to prove that to you, I can do this. If I type dot here, which is my ordinary object dot notation from JavaScript, if I hit dot, then I get a list of all of the properties associated with that object. So it is an object. And I've already told you that really the DOM is a network of objects. So that's kind of reinforcing the point. So the whole point of what I'm trying to get at here is that we can navigate the DOM programmatically. Here we happen to be doing it on the console, but we could just as well have this kind of code inside in a JavaScript function. So we can navigate the DOM. The next point is we can actually, how do we amend the DOM? Because that's really what will allow us to achieve dynamics in our web page. And I'm not going to type this out now, but you can do it in your own time if you wish. What I'm showing you here on the right is a sequence of statements that I typed into the Developer Tools console. And if I just talk my way through them one by one, the first thing I'm doing, it looks like, is I'm actually creating a button node. Okay, don't worry about specifics of this now, because we won't really be using it, to be quite honest. But what I'm doing in this statement here is creating a button node that I'm not attaching that button to the DOM structure though. So when I hit return here, I won't see anything happening over here because I have not changed the DOM yet. The next statement I'm doing is, it looks like I'm creating a text node. Then it looks like I'm attaching, so I have to check this again. Yeah, I'm attaching the text node to my button node. You know, essentially I'm putting some text, layering it on top of the button, but I have not attached anything to the DOM yet. So still, when I hit return here, there's going to be no change over here. However, when this statement is submitted, the effect of this statement is now to attach my button to the current DOM. And it's only when you hit return here, it's only then that you will see the actual button appearing on the page. So this screenshot is demonstrating the ability to amend the DOM, and the idea that once you amend the DOM, the browser will automatically reflect that amendment in what the user sees. And in this case, the user would see a button appearing on the page. So the browser is all about events. We say it's an event-driven programming environment. So it's all about associating browser events with some JavaScript code that you have written, and the JavaScript code, as it can do anything, but typically it would include amending the DOM, and hence you've got a dynamic web page. The browser, by the way, is also a single-threaded programming environment. We don't have multi-threaded. And thirdly, it is an asynchronous programming environment. So events can happen at any time because it really depends on the user's interaction. And the response to the event won't necessarily be immediate. It will happen sometime in the future. So you can't be guaranteed, for example, that a series of events will occur in a certain order. They can occur at any time, and the response, which is determined by your JavaScript code, will execute at some time in the future. The browser determines when it happens. It essentially kind of goes through a loop where it periodically checks, has any event happened since the last time I executed this loop? And if it has, then it will check to see if there are any event handlers, which is our JavaScript code associated with that event, and it will then execute the event handler. But this looping is where the asynchronicity comes in. Like when the event happens, the browser doesn't immediately respond. It'll only respond when it re-executes this loop check that it does periodically. Here I'm just listing some of the examples of what I mean by events in the context of our browser. And somewhere I found almost the full list of possible events. Most of them are associated with user interaction, though not all of them. You can have events associated with, for example, is it here? On load here, for example, would be, if the user interaction caused my JavaScript code to request an image to be downloaded from somewhere on the web, then when the image arrives in the browser, that constitutes an event, and we might want our browser to, or we might want some JavaScript code to execute as a result of the image arriving in the browser, presumably to attach it to somewhere on the page. So anyway, there's lots and lots of events that we can potentially write event handlers for. Event handlers, so we can add event handlers or event listeners to a web page. And what you do is you associate an event handler, which is just a JavaScript function. You associate an event handler with a particular element for a particular event. That's how you think about it. An event handler is linked to a particular DOM node for a particular event type. So it might be for the user left button click event associated with a particular button, or maybe even a text, maybe even a header or whatever. Now, how do we associate an event handler with a particular event for a particular DOM node? There are two programming styles. There's the imperative approach. There's the imperative approach, or there's the declarative approach. The imperative approach is where you do it programmatically. The declarative approach is where you actually include it in your HTML itself. So it's part of the HTML tag. Generically, it looks like this, whatever the HTML tag is. On is just the prefix of the event name. So it might be on button down, or on button press, or on mouse move. And you assign a function to this, essentially to this attribute of the DOM element. So it has all the characteristics. Here's our event handler function, which is somewhere else, coded somewhere else on the page. Here's the event that we want the function to be associated with. And here is the DOM element. Okay, it's a HTML tag, but that'll translate into a DOM element that we want to bind the event handler with. Whereas up here, when you do it in an imperative style, you actually start programming the DOM data structure itself. Just by way of example, we will be doing a lot of this event handling, but we won't be programming it using either of the styles that I showed you on the previous page because it's too cumbersome. But here's a simple example of how we would program an event handler using the declarative style. So again, you can see the detail on this if you wish in the sample code. So it's actually this sample here. If I just stop my Go Live server and restart it. It's not a very interesting example now, so don't get too excited. So here's the example. Here's my text box. If I type anything into the text box, when I hit enter, it'll just uppercase. So the event handler uppercases the contents of the text box, but only when I hit return. So the hitting the return in the text box is the event, and the DOM node is the actual text box itself. In terms of the code, you can look at it yourself, but it's included in the slide. Here's my event handler. Here's my declarative association. So I'm saying it's the text box. The event is the on change event, and the event handler is referring just to the function that I've declared up here. And you can see what the event handler is doing, and it's using very old ES5 syntax. So what am I doing? I'm grabbing, I'm getting the current DOM element, and I am taking its current value, and I'm just uppercasing it. Okay, I wouldn't worry too much about the detail of the code really, even though there's not a lot of code there. The overarching point is, here's my event handler, and the event handler is actually changing. It's making some change to the DOM. And as I've said before, whenever the DOM is changed, then the browser will reflect that. It'll go through its reflow and repaint modes or phases. The imperative approach towards these event handlers, there's a lot more involved. And I'm not really going to talk my way through this, because really this is a very ugly kind of coding style, which we never use anymore. It's very kind of spaghetti code like. But it's just doing DOM manipulation. It's setting up the link between an event and a particular DOM node, so you can see sort of here, I'm removing an event listener, I'm adding an event listener. So it's actually creating the association between the event and a particular DOM node. And I'm doing the same down here, but I'm doing it in a programmatic way. I'm not doing it in a declarative way. I'm not making the association down here in the XML code, in the HTML code, as I did in the previous slide. Okay, I think I've only got 2 slides, if you just bear with me. What I've been showing you in the previous slide and the one before it, what we were doing was using an API or a little library that's built into all browsers. And it's referred to as the DOM API or DOM library. And as its name suggests, it's an API that allows us to programmatically manipulate the DOM. And you've seen examples of that. However, using the DOM API is a very long-winded programming style. But that was all that was available to developers in the early days of dynamic web development. Then a library called the jQuery library came on the scene, and I think it was around 2006, I'm saying here. And what the jQuery library did was made life a lot easier for the developer, in that you wrote less lines of code. The jQuery library sat on top of the DOM API. So the DOM API was still being used and is still being used today, but we don't use it directly. So around 2006, for a number of years subsequent to that, and still today really, people use the jQuery library to implement dynamic web pages. However, there were downsides to the jQuery library, even though it it was extremely popular. It's the second most popular JavaScript library being used globally. It still is the second most popular, despite its age and its many drawbacks. In particular, you still write a lot of code, and it tends to be spaghetti code. And because of that, because of the deficiencies in jQuery, the next kind of phase that happened was the introduction of what are called single page app frameworks. So these single page app frameworks, they also talk to the DOM API. They don't use jQuery. And these single page app frameworks are really where we pick up the story. This is what we will be using in this module. In particular, as you know, we'll be using the React single page app framework. And so what React will allow us to do is to write much cleaner and physically less code and more readable code. But what that code is actually doing is ultimately it's manipulating the DOM, but in a much more kind of developer friendly programming style. Right, and so that's where we can start the real discussion next week now. We will start looking at React from next week, and for about 4 weeks, it'll take us to get through any reasonable amount of the framework itself. Okay, I've used up all my time, so if you're still there, thanks for hanging in. And if you have questions, I'm happy to hang around for any questions that you might have.